We've done several assignments this term in which you've used data in the Mystery Solar System table to help you describe the conditions on or inside one or two of the planets. In this question, we're asking you to describe two more planets using all of these techniques. In this way, you can see how to put together a complete picture of a planet's composition, interior heating, surface processes, and atmosphere. You should review what you've done in the previous Mystery Solar System questions as you work through this one. The first step in understanding what kind of world you've got is to figure out what it's made of. From what we've seen in solar system formation, you can make a reasonable first estimate of a planet's composition from its size and location. Remember that solid body accretion in the inner solar system is dominated by rocks and metals, while in the outer solar system this is mainly rocks, metals, and hydrogen compounds like water. If a planet doesn't get big enough for gas accretion, then those are the materials they should be made of. However, if it gets above 10 Earth masses, then you would expect hydrogen and helium to also be an important part of a planet's mass. Note that for bonus points, you can do the density calculations for the planets you're working on to see if they support your conclusions. Remember to show your work if you do this. You should also look at interior heating here. Is this planet large enough to have convection in the mantle, either now or in the past? Remember that we've seen that Mars is a transitional case here, so comparing to Mars would be useful. Also, what should the major heat source be? The composition of the planet can help you a lot here. The first question to ask yourself here is whether or not the planet has a solid surface. If it doesn't, then you just need to say that and move on to the next part. If it does, then decide how important impact cratering, volcanism, tectonics, and erosion will be on this world. Remember that while all planets receive impacts, not all of them show craters because of other geologic activity. So the number of craters on the surface will mostly depend on how much of the other processes are going on. Volcanism and tectonics depend mostly on internal heating, so your description of these will be tied to your answer about internal heating earlier in the question. Erosion depends on the planet having an atmosphere, as well as the planet's spin and surface temperature. So your discussion of erosion will be connected to what you have to say about the planet's atmosphere. Feel free to speculate on what sorts of features are likely to dominate the surface of the planet, provided it is consistent with the rest of your answer. We've already seen that the most direct way to determine if a planet has an atmosphere is through measuring the amount of greenhouse warming. So for the inner planet, you should calculate this, if you haven't already done so, and discuss what this means for the amount of atmosphere the planet has. You should also discuss how a planet like this is likely to form an atmosphere and what this means about the composition of that atmosphere. Your answer here is likely to be connected to what you've said about volcanic activity on the planet. Note that if you suspect that living organisms may be playing a role in the planet's atmosphere, then you should show that the temperature is consistent with liquid water on the surface. Even though we can't calculate the amount of greenhouse warming for outer solar system planets, remember that these worlds generally also have thick atmospheres due to their large masses. You should discuss how planets like this typically form their atmospheres and what those are likely to be made of. You should also discuss how intense the seasons are on these planets and whether or not there is enough Coriolis effect to produce strong winds and/or storms. Remember with all of these that your answers should refer back to the information on the Mystery Solar System table. Don't assume that your reader already knows the numbers. Clearly connect the data to your conclusions.